Hello, István. I've heard our new features ready. I'd like to see how it performs under reload.
Hello, András. Yes, the new feature is ready. Regarding performance, I think you should ask the QA team.
Come on, István. Is this all we can expect from developers? Is this all, István?
Of course not. Can you describe your expectations, please?
Sure. I have a nice gherkin for you.
Well, this looks executable. Let's run it. András, we have the reports ready. I think our new feature is doing fine. What do you think?
Well, quite impressive, and I'm especially glad to see clear evidence. This story we made, of course, up, but we as characters are real. My name is András DEZStomb. I'm from Eversoft, Hungary. We work on a large, multi-site, cloud-based project. I'm product expert of a team which develops, tests, and even operates a microservice. We have 50 of such teams, but we have only one performance engineering team. And you can imagine one team stands no chance in exercising all the stuff the others created. So we want to have a shift left of performance testing from testers to the development teams. The first step in this is taking a deep breath, risking being unpopular, and asking your team to do performance tests. The first results might be disappointing. I remember what happened when I asked first time. Look, András, we have 20 requests per second for you. This was, of course, fun and in some sense creative, but this was not the solution we could be proud of. Today, we have a performance testing framework which we love to use, and we thought it might be a good source of inspiration for you if you're looking for performance test tooling or ways to involve developers in performance testing. István will tell you how our framework is built up. Then I will reveal how much it has costed and why we like it so much. And finally, we'll show a real-life case of how we use it.
Hello, everyone. My name is István Andrási. I work with András in the same team as a developer. I will give you a technological overview of how we developers run performance tests. Let's start with a master plan. The first step is to bridge the gap between product owners and developers by writing down performance test expectations in Gherkin language. Next, we let developers combine existing tools they already use, for example, Cucumber, to parse the Gherkin files and run the Java code, JMeter, to run the tests in a distributed way, and Terraform, so that we can programmatically create a distributed test infrastructure and tear it down at the end. As a result, performance testing becomes reproducible, automated, and fun. So what's the basis of this? It's an executable test suite. And since we are Java developers, it's a jar file for us. It contains the performance expectations in Gherkin files. And at runtime, Cucumber reads the Gherkin files and calls our Java code for each step. Then our Java code assembles a test plan for JMeter, which JMeter runs on multiple remote instances and collects the results. Finally, both Cucumber and JMeter generate reports. So we have an executable test suite, and we have our system under test. Now, where is that button we promised in the title? In front of our automated test pipeline, of course. So let's push it and see what happens. First, infrastructure as a code is used to automatically deploy our distributed test infrastructure, master and slave instances. Then we obtain the current version of our executable test suite, upload it to the master instance, and with our proprietary super secret script, remotely execute it so that gmeter generates load on our system. And when the tests are finished, we download the reports and publish them so that we can show them around on sprint reviews. There is one final step, and that is to automatically destroy the test infrastructure so that we can save costs.
You might wonder how much this framework fun has costed. Let's see the bill. Fortunately, we had many of the technologies already in place and in daily reuse. So we use infrastructure as code to deploy our system to production. We use Cucumber to exercise functional tests. And we also use GitLab as an environment to work in and to run pipelines. We even have all this already integrated. Besides that, we had even gmeter in use as a sort of standalone stressing tool. So the first payment we had to make was to create the automation for the gmeter clusters. This took 2 weeks. Then came the hardest part, which you might guess is the mapping from Cucumber steps to gmeter execution plans. This took 4 weeks. And finally, we had to integrate all this in a nice pipeline so that also the reports are published at the end. So in sum, it was 2 months. And it was about a Scrum team of 8 people which worked on that. But imagine you have a team which creates a framework. Will the other teams use it? Will they know how to extend it? For such challenges, we have a nice pattern. We started working on our dream in the team where István and I am working. We laid the foundations. And after it was enough to be shown to others, we set up an incubation team, where we invited from every other team on our site, which is about 8, a single developer to contribute. We told those teams to think hard what is their most important performance test case and bring these with them. Then this incubation team got 2 sprints and developed the framework step by step incrementally. And after they were done, we had a basic framework which was capable of doing the first performance tests for every of our teams. Then the people went back, and now, ideally, we have 8 teams where we have 1 developer at least who knows how to run tests, how to write further performance test cases, and also how to extend the framework if necessary. Let's see why we like this. And let's also see what you might gain if you attempt integrating similar tools into your environment. So if you take Cucumber, of course, you'll have your performance expectation described in a language even business people will understand. Besides that, if you're also doing functional testing in Cucumber, you can combine these tests nicely. Then, if you're not yet using infrastructure as code to specify how your runtime environment looks like, it's worth to push this underneath gmeter. And then you'll have clearly specified and fully reproducible test environments. And you can scale it as long as your money permits. And if you go home at night, you have no fixed costs. If you don't use yet GitLab as an environment to work in, I can very much recommend it. It's already nice to you if you use it alone. So if I look at this, I did a lot of experiments, And I could now go back to each and every one of them, see what I specified as an acceptation, look at the test environment, and also download the reports. And then, if you start collaboration, you'll have, for every of your branches of your test specification, a dedicated cluster where you can run the test. So if there are multiple work streams, they do not interfere with each other. There might be a natural question on the tip of your tongue, sorry, which is, why didn't you look around? Why did you make your fun in developing your own framework? And the answers are quite simple. We didn't want to spend weeks on looking at third-party software. We didn't want to spend weeks on contracting other companies and getting permissions for that. We just wanted to start quickly as possible. And if our framework turns out to be too simple, we can add features later and incrementally. We have lots of reuse between the technology we use for a product and the technology we use for a test. It's about 80%. This is, of course, cost-saving and time-saving, but there is one much more important thing to it, and this is connected to the notion of having tests as not second, but first-class citizens. And what does this require? This requires, of course, proficiency, and you will be only proficient as a developer, really, in the tools which you use on a daily basis. That's one point. And there is another more subtle point. Giving first-class treatment requires things like refactoring and playing around. And that needs kind of passion. Now, István told we are Java developers. Actually, he is, I'm less. And what are we passionate about? This is our bright side of life. In the best moments, Java developers do writing product code in Java. In the second best moments, they write tests in Java, maybe Cucumber. On average days, we might be automating our infrastructure. But what we do not like at all is manual work. And unfortunately, specifying tests on the JMeter UI is that. And what we equally dislike is digging XML files. And unfortunately, test plans of JMeter are XML. And now if you think of our framework, what we achieved is shifting the specification and writing of performance tests from a Java developer's hell to almost a Java developer's heaven, if I might exaggerate. And now we promised a lot. Let's see how this works in daily practice.
We have taken some real-life examples, screenshots of our recent performance testing activities to show you how it works. It looks like András had some fun playing around. He's smiling there. Let's look at some of the changes he committed that day. As you can see it, he rewrote a sentence in one of our test cases to increase the duration of the test. In another change set, he also modified the number of slave instances in our distributed test infrastructure so that he can multiply the load on the system. For every change he did, a new pipeline was created automatically, consisting of 3 stages. The first stage manages the test infrastructure. The second stage runs the test. And the third stage publishes our reports. Let's look behind those green icons and see what happens in the background. So first, our infrastructure is updated because András requested 3 more instances, increase the count from 2 to 5. And let me point out that it took less than a minute to update the test infrastructure, which is quite nice. And now our updated infrastructure is ready, so let's run the tests. In the second stage, as we can see it in the middle of the logs, our sentences assembled a gmeter test plan, and gmeter started to execute it on remote instances. After all the samples were collected, we ran a final assertion, and it passed, which meant there were no failing requests. So finally, our test is green. As a last step, the results are collected and reports are generated so that we can show that reports and examine them. So let's see some of those reports. It contains a nice graph of, this is a graph of hits per second. There is an even fancier graph with more lines of average response times. And as a little extra, we have a colorful cucumber report. We know that managers love these so much, so it's important to have it. And there is one thing left we must not forget, and that is to automatically tear down our test infrastructure so that we can spend that money on team building instead.
Finally, let's reiterate in a bird's eye perspective what went on in our team. We went there and asked them to do performance tests. In this, we gave the team complete freedom. As a result, we were rewarded with this great combination of tools, with this framework, and the real first-class treatment of our performance tests. We encourage you to try out these tools as well if they fit your technological landscape, but we encourage you even more to let your developers find their ways in performance testing. Now, we'd be glad to answer questions.
If there is any.
We'll see.
I can see there are 3 questions. So the first one is, what is the cost to maintain this tool?
That's a good question. We haven't measured it.
And it's a bit hard because we are writing production code, and as we are writing production code, we are writing performance tests for it. So I think it's another benefit that developers write tests as much only as production code. Sometimes you have separate action items for writing tests, but we haven't explicitly measured how much time it takes.
Yeah, so the standard tooling which you have included is there in your product anyway. This you will maintain and upgrade if there are security patches. And the test steps, yeah, they break if you change your interfaces. So
yes, and maintaining the test code basically means adding new steps in the Gherkin file, reusing already implemented sentences, and sometimes when you have something new, then you have to do something in Java. But after a while, I think you will have so much implemented, then even product experts will happily add new sentences and it will work without a developer touching it.
Maybe I'm bypassing the right answer, but I'm not necessarily happy about showing extra costs about tests, because if you have them shown as extra costs, then somebody might turn up and say, why do we need this? So it's just part of, if someone asks for performance, the pricing of the tool is included in getting that performance. This is how we try to play it.
Thank you. The next question, what is the learning curve for teams to use this framework or solution?
Well, since we did it in a way András explained, by pulling in developers from every team, That way, we have no onboarding training or something like that to use the framework, because if the guy who were included in the incubation team went back to the team, then he started to work together with the others, and after a while, all developers in a team learned how to use it by pair programming and implementing new features. And we also rotate the responsibility of writing performance tests. So if two people already wrote performance scenarios, then a third one has to do the next. So he must learn how to use it.
Thank you. The questions are coming and coming. Did you think about putting everything in a container or Docker?
Yes. We have our test artifacts as jar files, and we already published Docker images that run the tests, but we do not use them yet because for now it's much easier to upload the jar and run it directly. But putting that into a Docker container is already done, but not used yet.
Were there any proof of concepts before you started to develop this solution?
Yes, because our functional tests already used Cucumber mapped to the Java code, this without gmeter, and it worked quite well for us. So the next step was to include gmeter as well and specify new or implement new sentences that create gmeter test plans.
Thank you. And one last question. How easily can you fit your framework for different projects?
I think it's just a general idea of combining existing technologies. So if you have your own scenarios, you could even reuse our test plan assembling sentences. You only have to add your own sentences saying, I create 100 users, which you have to implement. How do you create your 100 users? We implemented it on our system. So it can fit other projects, and even with different technologies. So for example, we use Terraform for infrastructure as code, but you can use anything else if you're working with other technologies.
Thank you. Is there any other question from the audience right now? Okay, I cannot see. No more questions. Thank you. Thank you for this presentation, and see you at the next presentation.